Hello, ladies and gentlemen. This is Dr. Robinson, and we're going to continue our studies. We are talking about adding and subtracting radicals. So, let us get started. Adding radicals is like adding fractions, I find. So, when you're adding fractions like 2/7 plus 2/7, how do we add fractions? Well, if the denominators are the same, all you have to do is leave them the same. So that's the first thing about fractions. That'll be 7. When we do our addition or subtraction, we could add the top numbers. That'll give us a new top number, and the denominator remains the same. So how does that relate to radicals down here? I will show you. You got an outside number and an inside number of the radical sign. So a number outside the radical sign, number inside. I will say the outside numbers, you can reckon those to be like numerators. Those are the outside numbers. So we could add the numerators, or the outside numbers. We really call them coefficients. The inside number, those would be like the denominator. You don't have to add them. Like the denominator, they must be the same in order to add. So your answer, if you notice, is going to be 4 on the outside, but the inside number stays the same. So 4, 7. 4 radical 7. And that is your answer. You have just added radicals. So it's similar to adding fractions. So here are the steps to add or subtract radicals. Simplify the radicands. That's the number on the inside of the radical sign, and it says simplify. You might want to check out my video about how to simplify radicals. Add or subtract the coefficient. That's the number in front of the radical sign. And remember, the radicands must be the same before you can add or subtract. So let's look at an example. So here's a little quiz that you can quiz yourself. So good luck. 4 radical 3 plus 2 radical 3. What do you think? Hey, the radicands are the same, and all you have to do is add the outside numbers. So if you said 6 radical 3, you are correct, because 4 plus 2, the 4 plus 2 will give you the 6. And all you have to do is leave the inside number the same. They must be the same before you could add. That's why you get 6 radical 3. Here's another one for you. Question number 2. 5 radical 2 plus 5 radical 7 plus radical 7 minus 2 radical 7. All right, give you a second to think about it. What do you get? Well, they all have a radical 7 in the inside number. That's the radicand. That's like the denominator. They're all the same. So I can add or subtract the coefficients. So here I got 5. There's no number here. I'm suspicious. If there is no number, I remember in algebra, you can put an imaginary 1. So if you didn't put that 1, you're going to have a hard time with the answer. And then you're going to subtract 2. So 5 plus 1 gives me 6. And then 6 minus 2 gives me 4. So my outside number is going to be 4. And my inside number stays the same, radical 7. So there is my answer for radical 7. And let's pull that out. Yes. I got 100 on my quiz. So if you understand what's going on so far, great. If you're uncertain, rewatch the videotape, write down your questions, bring them in. Here's some other questions for you to try. See if you can get them correct. These look like the same questions, so you got lucky. Here's some different ones. And 4 radical 7 minus radical 7. Good cute trick, so be careful of that radical 7. And there's x's now. Let's talk about that x. They're the same on the inside. So the radicands are the same. So all I'd have to do is just add up the outside numbers. So 9 plus 3, wouldn't that give you 12? And radical x, so let's just pull that out. Yes, 12 radical x. So add your 9 and your 3 to get the 12. And the inside number has to stay the same. And in this case, we have a variable representing a number, so we know it's going to be x on the inside. So take a look at number 3. See if you can get that one. I'll leave that to you. Here's a handout I plan to give. And if you come in with questions, I'll be glad to answer them. Now, let's go on a little further. What happens when the denominators are different when we're trying to add fractions? Or the radicands are different when we're trying to add them? Well, when we deal with fractions, we have to have a common denominator in order to add them. So here our denominator would be 20. Our common denominator would be 20. So we'd have to multiply by 4 both top and bottom number to make this 1/5 of 20. That in a sense would give us 4 over 20 plus 2 over 20. So therefore we could add it and we'll get 6 over 20. Well, on the bottom I have radical 5 plus 2 radical 20. Here's what we have to do. We have to get a common radicand. So instead of trying to make the 5 a common radicand, I'm going to leave the 5 alone, and I'm going to break down this into 2 parts. A 5 times a 4. 5 times 4 will be put under the radical sign. And if you checked out my radical multiplication of radical numbers, you'll see why that is so. So 4 times 5 is 20, and they're both under the radical sign. And I picked 4 on purpose instead of 10 times 2, because 4 is a perfect square. So I can take the square root of that, which will give me 2. And notice I have a 2 on the outside here, which is being multiplied by that. And I have this radical 5 out here. So I got to multiply that. So 2 times 2, let's scroll down a little bit more. 2 times 2 will give me 4 radical 5. So, and now let's bring this radical 5 down there because we're trying to add that. So we really have radical 5 plus 4 radical 5. And if you say 4 radical 5, don't forget there's an imaginary 1 that goes here. So 1 plus 4 will give you 5 radical 5. So there is your answer. So what really they could have written, instead of 2 radical 20, they could have wrote 4 radical 5. So notice what we're doing. We're simplifying this number to get it to be a common radicand. So try to simplify first. So that's our new rule we're going to be dealing with. So we're adding with different radicands. Hello, Chantel. So to add or subtract radicals, simplify the radicands. So we're going to simplify. Again, same steps. Add or subtract the coefficients of the radicals. The radicands must be the same before you add or subtract. So let's take a look. Here's a couple questions. 2 plus radical 50. Well, I have to break down that radical 50 into a number that multiplies to give me this number here. So most times, if I have one of the numbers already broken down, then that means this number has to have a 2 in it. So 2 times what is 50? If you said 25, you are in good shape. And 25 is a good number because it's a perfect square. So that means we can get the square root of 25. The square root of 25 is 5 times the radical 2. So this really should have been written as 5 radical 2. So we're trying to add radical 2 plus 5 radical 2. Remember the 1 there? 1 plus 5 equals 6. And radical 2 is inside, because now we can add them. So if you said 6 radical 2, you're in good shape. Here's another one. 80, radical 80 minus 5. So radical 80 must have a 5 in it. So 5 times what equals 80? I know, 16. 16, by the way, happens to be a good number to choose because it's a perfect square. I know you could have said 8 times 10, but there was a 5 here, and I'm trying to get the same radicand here. So 5 is what I need, and 16 times 5 is 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 80. And since 16 has a square root around it, that's really 4, because the square root of 16 is 4. 4 radical 5. So really, what they could have done was, instead of writing 80, radical 80, they should have wrote 4 radical 5 minus radical 5. Put an imaginary 1 here. 4 minus 1 is 3, and radical 5 is in there. So there is our answer. So I hope you got that one right. Uh-oh, here's a long one. Get a little space on this. So let's see. I got radical 8 down there. I gotta break that down. I got an 18. I gotta break that down. And I got a 3. Well, that's already broken down, so I can't break it down anymore. So I better leave that. Okay, so let's see. 4 times 2. I picked 4 because 4 is a perfect square root. Perfect square. So let's bring down the 5 first. We have a 5 there. Times the radical 4. And that's a perfect square root. So that'll give us 2 times radical 2. And don't forget we have a 5 still sitting out there, which is going to be multiplied by that. 5 times 2 is 10. And don't forget we have a radical 2. So now, so we've cleared that up. So let's look at this. 9 times 2. 9 times 2 is 18. I picked 9 because I was interested in either getting a 3 or 2 radicand, but 3 would have been good. 6 times 3 is 18, but I don't have, 6 is not a perfect square, so I like 2 better because this will give me the radical 9 that I need, because the radical 9 is a perfect square. So let's circle that. Let's first bring down the 3. We have 3 times radical 9. The square root of 9 is another 3. And we have times that by radical 2. So 3 times 3 is 9. And we have a radical 2. All right. Plus, we have a radical 3. That's a different denominator. Well, let's look at what we can do. Well, we have 10 radical 2 minus 9 radical 2. That'll give us 1 radical 2, or just radical 2. We don't have to write the 1. We still have a plus 3, radical 3, so I cannot do anything with that because the denominators or radicands are different. So I have to leave it as it is. So my answer is going to be radical 2 plus radical 3, some type of binomial radical. Am I allowed to have that? Yes. As it goes into some other good stuff you'll get in to rationalization of denominators and things, so you'll see that kind of stuff. So that's great work. So I hope you understood what went on. Here are a couple for you to try. See if you can get them. So let's scroll down a little bit. There's that third one there so you can see it. So see if you can do them and bring in your answers, and we'll be glad to go over it in class. So I hope everything was fine and you understand everything. If you have questions, write it down, watch the video again, try the problems on your own. Here's some more questions you can try. The more you do, the better you get at this. I guarantee you, you'll get good if you keep trying. Here's a handout I plan on giving. So try some of these questions. They have variables as well. Another handout. So here's a quiz I plan on giving you. So this one is a practice quiz. So see if you can do it. I hope you found the lesson pretty easy. And write down your questions. Write us, robinsonmath@aol.com. If you need more questions, I'll be glad to give them to you. Just send me an email. Uh-oh, there's the real quiz waiting for you guys and gals. So I hope you found this helpful, and if you have questions, write them down. I'll be glad to answer them in class. And this is Dr. Robinson signing off again. See you in class tomorrow. Bye-bye.